Amazing people, what's up? Students, lovers of chemistry out there, each and every one of you who have made this journey an absolute blast for me. I'm so excited to be here with you on today's episode of Question for the Day. And on today's episode, we have a question on electrochemistry that says, how much copper will be deposited at the cathode when a current of 2.5 amperes, this A over here stands for amperes, is passed through a solution of copper sulfate for a time period of 40 minutes. So they're asking us how much copper. So whatever we calculate, our answer should be in grams, because that statement how much is simply asking us for the amount of copper in grams, or the mass of copper produced. So they've given us some details in solving this question. They've given us the relative atomic mass of copper, which is 63.5 grams per mole. They've given us the Faraday's constant, which states that you need 96,500 coulombs to move 1 mole of electrons. And then they've also told us that the equation of the reaction shows that you need 2 electrons to deposit 1 mole of copper. So let's solve this question step by step and see what we'll arrive at. So first things first, they've asked us to calculate the mass of copper. Now, the mass of a substance M is simply equal to the number of moles of that substance multiplied by the molar mass of the substance. Now, before we can use this formula, we need to make sure that we have all the necessary details. We have the molar mass of copper, yes, but we do not have the number of moles of copper, and we are looking for the mass of copper that is produced. So now that we do not have the number of moles of copper, we need to calculate the number of moles. How do we get it? Now, since this is electrochemistry, to get the number of moles, there are some other details we need. We need to calculate the total charge that was used, Q, and then we need to calculate the number of moles of electrons that have been used in this chemical reaction. And then we use that information to calculate number of moles. So let's do each and every one of them step by step. So to calculate Q, or the total charge that is used in the chemical reaction, the first law, or Faraday's first law of electrolysis, states that Q is equal to I multiplied by T. Q here stands for the total charge used. I here stands for the current of electricity in amperes, and it is 2.5, times T here stands for time in seconds, and we have 40 minutes. So to convert this to seconds, we simply say multiplied by 60. When we say 40 multiplied by 60, that gives us a figure of 2,400. So we have 2.5 multiplied by 2,400. 2,400 times 2.5 gives us 6,000 coulombs. So now we have the total charge that has been used in this chemical reaction to be 6,000 coulombs. Now that we have the charge, let's calculate the number of moles of electrons that was used. How do we do that? We simply use the Faraday's constant over here. Now, the Faraday's constant tells us that you need 96,500 coulombs to move 1 mole of electron. So we've calculated our own charge to be 6,000 coulombs. So 6,000 coulombs will now move an unknown number of electrons. Did you see what I just did over here? So at this point, we can cross multiply. And when we cross multiply, it now becomes 96,500 times, of course, we're using a question mark over here. So times this question mark is equal to 6,000 multiplied by 1. So now 6,000 multiplied by 1 is the same thing as 6,000. So to find this question mark, we divide both sides by 96,500. So this cancels this. It now becomes 6,000 divided by 96,500. So when we say 6,000 divided by 96,500, that gives us 0.062 moles of electron. What this means is that 0.062 moles of electrons were displaced by 6,000 coulombs, which we calculated to be the charge that was used in this chemical reaction. Now we are not done, but we have calculated our number of moles of electrons to be 0.062. So what do? The next thing to do is to use that information to calculate the number of moles of copper that it produces. How do we do that? Simply, now look at this equation over here. This equation states, or it shows us, that 2 moles of electrons deposit 1 mole of copper. Now we've calculated the number of moles of electrons that were used in this chemical reaction to be 0.062. So 0.062 moles of electrons will now deposit an unknown number, or an unknown number of moles of copper. At this point as well, we can also cross multiply. When we do, it becomes 2 multiplied by the question mark is equal to 0.062 multiplied by 1. So therefore, to find this question mark, we divide both sides by 2, divided by 2. So the question mark is now equal to 0.062 divided by 2. That gives us 0.031 moles of copper, or Cu. Now that we have the number of moles of copper, we can now use that formula that we stated initially at the beginning of this question, that states that mass of a substance, M, is equal to number of moles of that substance times the molar mass. So now we have the number of moles and we have the molar mass. So let's calculate the mass of copper produced. M is now equal to the number of moles. We calculated it to be 0.031 times the molar mass of copper. You can see it over here, 63.5. 63.5. So when we do our math, we have 0.031 times 63.5. That gives us 1.9685 grams. So from this question now, we've solved and we've gotten our answer. We've gotten our answer to be 1.9685 grams of copper was produced. So I'm sure you saw how each and every step was taken. I'd like you to please subscribe if you have not, like this video, and share to as many as you can. And I will see you in the next video.